Hello everyone, welcome back within our machine learning session. Um, and we are starting session 2 on machine learning. So we learned about machine learning, right? So let me recap quickly so that we will be on same page. So we learned artificial intelligence, what is AI, and within that we learned about um, let me pointer, right? So yeah, artificial intelligence. So artificial intelligence, nothing but is a multidisciplinary field of computer science that aims to create system capable of emulating and surpassing human level intelligence. So that's what the goal. So in AI, we would like to create a machine or system which can mimic the human behavior, right? And the way human works and the way the human has intelligence, that's level of intelligence we would like to achieve with machines. So that's the machine learning, artificial intelligence. In machine learning, uh, this is the uh, another subfield of artificial intelligence in which we would like to we would like to let machine learn from data and automatically predict the future or automatically do the prediction based on the historical data it has learned. Right. So machine learning in nutshell, it's nothing but it's a subset of AI focused, and it is a subset of AI and focused on building algorithms and model that allows computer to learn from and make a decision based on the data. Right. So we allows machine to learn from the data, build up algorithms or come up with algorithm, and based on those algorithm do the prediction. So unlike so this is the machine learning. So unlike traditional software that relies on explicit programming, right? So in traditional programming we were doing explicit programming. For example, we understood there, right? Let me bring that slide up. Give me a moment. Yep. So here we learned about this is a traditional software development, and this is software 2.0, where machines learns, come up with algorithm, and based on those algorithms, it get unknown data and predicts unknown behavior or output. Right. So with that, uh, we are concluding that unlike traditional software that relies on explicit programming to perform a task, ML system automatically learn pattern from data and improve their performance over time. So as there are multiple way of learning, right? One is online learning and batch learning. So uh, this concept you will be seeing online versus batch learning. So let me call it out. So you will see, which is the pen, right? So another way of categorization machine learning is so ML can be categorized in two parts. One is BATC, batch learning. Another is online learning. So batch learning, in this one, what we do model model training, and this model training we do offline. Means we get a huge amount of data and train the machine, and then we get the model. Okay, and this model goes and deployed in production to production. And in production, or let's say internet, we deploy it, and then we allows customer our live data comes in, and this system does the prediction, right? So this is live data comes in production, and this systems does prediction, and this process, whole process, we call it inferencing. So we call it model inferencing as well, right? So we train, and during train we do train and test also. Okay. So so the way the traditional software we test, there is a test concept as well, and then we deploy to production. In online learning, what it does, these systems, whenever this offline batch learning model we do know, whenever we would like to improvise it, we have to make it offline, then retrain, and then deploy to production. But here we build, we train and test with live data itself. Data, and it does prediction. So for these two type of scenario, the two type of process, it belongs to two different use cases. In some of the use cases, uh, there would be scenario we build a model, we don't need to train it. Training online in production is too much costly. But here, what could be the scenario? We want to be a latest always. Okay. So whatever data comes in, this model need to get trained. For example, scenario would be stock price prediction, right? So in this scenario, you need always fresh data, right? And those fresh data need to be ingested. There could be scenario of recommendation. Dation. So recommendations, price recommendation, product price. Okay. So product price recommendation, if you would like to do, you might be looking to be competitive with your competitor. You should be always getting all those competitive product price in the market, and you have to train your model to predict latest price, right? So in this could be the scenario where in this batch scenario there might be the cases where you have trained once, and for a period of time for 6 months or so you don't need to bother about that, and based on that model itself this prediction has to go. For example, student student selection model. So for a student, if you are like to have a model which will say that given new students selection possibilities, so for that you don't need always very recent data, right? Based on the last year of exams up to our historical exams results and students being passed or failed, your model will be behaving similarly next year as well, for next year student also. So demography will not change very frequent here. That's where you don't need. So these two are different scenarios. Just to make you guys understand. Uh, so we have these two. Another way of categorizing ML system: batch learning or online learning. All right. So we came from this machine learning definition, right? So we'll try to decode that definition once again. So yeah, so that's where it says that unlike traditional software that relies on explicit programming to perform a task, ML system automatically learns pattern from data and improve their performance over time, right? So when we say over time, means if we are keep on training with the latest and greatest data, it will improve its performance. All right. And then we learn about, yeah. So we learn about artificial intelligence, machine learning. And in machine learning, we were learning type of machine learning. So we learned about supervised machine learning, unsupervised machine learning, semi-supervised machine learning, reinforcement, and we touch upon deep learning, right? So in these types of machine learning, when we say supervised machine learning, let me bring this pointer again. So when we say this supervised machine learning, what does it mean? So we'll learn about supervised machine learning. Those are the way of uh, making machine learn is in which the model is trained on labeled data. We learned about labeled data where data has been labeled, means it has been given information what this data is, means data, how data will get labeled. If data has data has label, that means data has metadata, right? So data labeled means data will have some metadata, and through which we can label this out, right? Means if I'm giving an image of particular animal, then we during giving this image, I have labeled it. For example, animal. This is mouse, right? So these are the something, and it's um, a four-leg animal, right? So these are the labeling. So if we have labeled the data and given this labeling, then we call it labeled data. Understand? And where, so in this scenario, input data is labeled, then expected output will be decided based on this labeled data on which the model is trained on. So model learns to predict the output for new unseen data based on its training. So what are the uh, data we have given and are based on what data we have trained on, accordingly the model will be able to predict the output. Clear? So example of uh, so this is the supervised machine learning. So supervised machine learning's example is image classification, spam email detection, means if this email is a spam or not, right? So classification and regression. So where so when we are saying classification, we can classify that image is what type of image. It is animal or flower, something like that, right? And when we are saying that regression, where we would like to get to know only one value, that is, for example, this email is spam or not. This is a kind of regression, only one value. But mostly when we talk about regression, always we expect numerical value. So when we are expecting mail is spam or not, 0 or 1, 0 indicates no, not spam and 1 indicates spam, that is, we can consider it regression, right? Then we learned about supervised learning. So this supervised learning is type of learning. Let me again bring this point. Okay, all right. Okay. So, yeah, this is supervised learning. So supervised learning, sorry, unsupervised learning is a type of learning that deals with unlabeled data, where we can't, we didn't provided or trained or labeled data, or we can't label also. Okay. So in those scenario, if we have trained model on unlabeled data, the model seeks to find a hidden pattern automatically or structure in the data without predefined output. So output is not given that hey, these are the data which are animals or flowers or something. It is this machine's models will be identifying that structure automatically. So that we call unsupervised learning. Example of those would be clustering, right? So here, if we would like one case, we can consider customer segmentation. Means if we would like to segment the customer, if it is premium customer uh, or general customer or just a normal customer, right? So in those scenarios, we can use uh, and those kind of models, and we will call it clustering, right? And another thing would be anomaly detection. In that scenario, we can use it, right? And reinforcement learning. The reinforcement learning an agent. So here, agent or system learns by interacting with an environment. So it will interact with environment and learn automatically and receive the feedback from the in the form of reward or penalties. So if it is does good, gives the right output, it will get a reward. If it is wrong, then it will get penalties. So that's how this machines learns. So we call it reinforcement learning. Here, classification and controls are the use cases, and the goal is to maximize the cumulative reward over time. So here, the goal will be when we are giving penalties or feedback, right? So the system will learn or improvise based on that. That's the reinforcement example. So example could be the self-driving cars, right? Are robots playing games. So self-driving car where car itself goes into environment, gathers the data and learns it. And if there is any feedback, it get penalized. For example, if it is not able to recognize a small object, then it will get negative point or penalized for that, and then it will learn, and then it will pay attention on those things. Or game playing agents, the agents which will play the game automatically, those are the reinforcement learning. So in the game industry, other side of agent will play with you. So what it does, the way you play the game, it learns and it's do better than you, right? So that's a supervised learning, right? And core algorithm in machine learnings are we learn linear regression used for predicting continuous value based on the relationship between input variable, right? And uh, decision trees. So this is a classification again, right? SVM, support vector machines. These are the common algorithms, right? So now let's jump into few examples or few other understanding how does it work. So regression, what is regression? So this is a regression and use case where we are considering this is a temperature and this is a number of Bayes scalar went for bicycling. Okay. So what it does, it's based on these data points, it puts all those data into T2D space. So this is the temperature on x-axis, and this is the cycle renter has been happened based on the temperature. So as data has been placed here, right, you can see the data points. So what this model does, this model draws a straight line, try to fit all the data point, and then with that line, it's prepare a formula, right? And it's understand and it's prepares a formula like that formula becomes fx 35 plus 1.5 into x, right? So whatever the value of x is, correspondingly based on this formula, the value of y is coming up. So just to make you guys clear, when we say here, right, let me bring this pen. So, right, okay. So this x variable we are calling, right? These are independent variable. Means this x is not depend upon anything. And this is your y. This is dependent variable on x. So whatever the value of x is, that value will decide what value of y will be, right? So we call it dependent and independent and dependent variable. So this is dependent, y is dependent, and x is independent variable. So based on this data points, and it's try to overlapping all data points, it creates a line, a straight line. And if we are able to draw a straight line, you already know we can have a linear equation, right? So this is nothing but a linear equation we are able to come up. And whatever next x value we will get with this formula, I should be able to derive value of y, right? So I can predict whatever x values is, according to that, I will be able to predict the value of y. And with that formula, I will be calling it a regression, where I'm able to get the number value. Hope you understand now, right? So this is the regression example and how we plot the data, we visualize data in this way, and then we draw a linear w- line, and that line try to fits all the data points, and that equation becomes a formula, and according to that, this regression model will be predicting uh, based on unknown data. Clear? Now let's move to next. Next is classification, right? So in machine learning, for example, here, if you go in supervised machine learning, you will see we have regression. Supervised machine learning, we have classification and regression. Regression line we understand, right? Classification we are trying to understand in more detail. What is it? So classification is nothing but is, for example, this is the uh, whole data set. Okay, whole data set of patients or humans can understand. Lab data, right? Heart rate, height, weight, right? So these are the data points of a human. So while building the model for a classification, so thing is based on these given data, again it's supervised. So we already have supervised and its data point here. Okay. So what? So traditionally, in machine learning, I just to make you clear what is training and validation. So as I was discussing, whole data set will get divided in two parts. One part, most of the more than 40% of data we take for training purpose, and based on that data, we train the model, and then we do testing also, right? So we do the validation of that model based on which we have trained and see what is the result, and it should get match, right? So in this kind of scenarios where we have uh, lab report, heart, weight, height, right? So for this data again we will plot it, right? Here we have plotted, and then based on that plot it will understand the pattern. Okay, so it understand the pattern, and then it recognizes uh, the unknown data. It's get tested an unknown data, and there it says that okay, this was the correct prediction, this was correct, these are wrong prediction. Then we measure the accuracy as well. Okay, so why we do? Because we would like to uh, from here we will like to measure accuracy of model. Okay, and how we see it? We see it based on this matrix, and this matrix we call it confusion matrix. I will let you know what is it. So just you need to understand at high level, right? So this is the actual, right? And this is the predicted value. So actual was means based on the given data, diabetics, for example, this is a, report, and this is the diabetics ticks prediction. So based on level data given, these are the medical conditions, and this guy is uh, not diabetics. This one diabetic. This one not diabetic. This one diabetic. This one not diabetic. So when we do the testing, right? So we have actual data, but we did the testing. Now we saw that what is the difference. So here actual was diabetics and predicted is also diabetics. Mm, This is both true condition, right? Here what happened? Actual is diabetics, but predicted is not diabetic. Here actual is not diabetics, predicted is diabetic. Here we actual is diabetics, actual is not diabetics, predicted is also not diabetic. That is 900 cases, right? So with this confusion matrix, we should be able to build the intuition how much accuracy model is bringing up. Okay. So with this, we will be able to figure it out accuracy. And this is nothing but this is the plot of the same data here. So in this, it will not be always a case that it will be linear, right? So based on this confusion metric, this is the plotting, and its plotting will also give uh, this kind of graph. Next is clustering. So clustering is part of unsupervised learning. Unsupervised learning. And unsupervised learning means we are having non unlabeled data. Unlabeled data. In another sense, what does it mean? For example, if we have so these are input A, B, C, D, but output output is not given. Okay, so here we don't have output, means this data is not labeled, just we are getting this parameter. So to understand this scenario, what is happening, that this is the flower. Okay, this is the flower. So what it does, it says that its height is 6 centimeters, suppose, and how many pallet it has. So this one has one, two, three. It's three. This one height is 5. This has pallet 3. This is height is 2. This one also has palette 3. Here height is 1, palette 3. Height is 3, palette 8. You will count. Okay. Here height is 4, palette 4. Right. So these are, this is the input data. Okay. This is the input data, and sorry, this comes, this comes under, right? So this comes under unsupervised learning, right? And here we haven't given any output. So this is the input. Sorry. So this is the input. Hmm, okay, let me change to that pen. Okay. So these are the input, and automatically it's has some inferences, understand its matrix, and it is able to put the plotting here, right? So the similar, wherever similar attributes matches, it's trying to keep those objects. So what it will do, it sees that 333 pattern, I should be keeping it nearby. Okay. And even though in that 5 and 6 are too much closure in this 3 3. So these two will be close together. So if you will see these two object here, it has been closed, kept here, if this is the attributes, right? Similarly, these two are same, but these compared to this, there is differences, right? At least 3 to 4 and 5 point difference. But within these two, they are pretty similar in terms of height. So these two will be getting placed in the same nearby, right? So if you'll see here, this guy has been placed here and this guy has been placed here, correct? And these two guys, you will see it is 8 palette and it has 3 and 4 also, right? And height. So reason why, if you'll see, these has been placed nearby. So that's how the clustering works in machine learning. Understand? Hope you understand this case at high level, right? So this is how clustering works. Now let's try to understand deep learning. So we had supervised, semi-supervised, reinforcement, and this is the one of the deep learning scenario, right? So in that deep learning scenario, we will understand computer vision. What is computer vision? So computer vision is nothing but identifying objects, right? So in this one, you will see the uh, this is the one of the scenery, and out of it, it extracts the objects, right? So based on this layer of graph, it would be able to depict the areas where this objects belongs, right? So it can try to figure it out. This is the area where I'm able to see one object. This is the area I'm able to see one object. Here one, right? And so on. So this field of study is called computer vision. Okay. So right. So this is the uh, field of computer vision. Just to understand it. Okay. Let's move next. So application of computer vision is again image classification, object detection, smart segmentation, right? A person with dog on the street, right? In face detection and recognition, it will be able to recognize who is who from the crowd, right? Optical character recognition, OCR kind of scenarios is being achieved in the banks. So that's where we don't need to uh, type it automatically just by showing the image or report, the machine will be able to extract. The one example is a bank. In bank, check deposit, right? ATM machine. In ATM machine, when we deposit the checks, it automatically extract the information and match with the uh, whatever customer it has within its database. So this is the application of computer vision. So we will learn natural language uh, and computer vision in more detail uh, in a uh, different way, in more detail. But this is the what we have. And natural language. What is the natural language processing? So natural language processing is the field of machine learning where we are our systems are able to understand the way the human natural language other persons understand, right? So the way the human interact with human in a natural language way, similarly if machine is able to interact with human in their humans language, that field of machine learning is called natural language processing or natural NLP machine learning. Okay. So in these, there are fields which we call text analysis and entity recognition, right? So text analysis, whatever text has been given, it will analyze and understand that text, right? And entity recognition. So from that text, it will be able to recognize what is the entity, what are the entities part of the speech, what actions it's trying to say from that natural language. Sentiment analysis is another area where in natural language we get a lot of text and we try to predict that text is positive or negative. For example, in case of product feedback, we try to do the sentiment analysis. Then speech recognition and synthesis. So this is the field where we try our machine tries to recognize the human based on speech, right? So Alexa, Siri are the example of speech recognition. Machine translation. The machine is getting used to translate one language to another, right? So for example, we call it um, English to Chinese. Translation is called machine translation because machine is able to translate it. So example is Google Translate. Google Translate. Now you can correlate the uses of this system. Semantic language modeling. So this is where semantics of language will get extracted and accordingly it will do the operation, right? So, so if in the case of if I'm asking there is a apple, give me apple, or I can say I like I like apple, right? So based on the context, it will be able to understand the semantics. Am I talking apple as a phone or apple is a fruit as a fruit, right? So, so based on the context, it should be able to figure it out automatically. So this study is called sentiment language modeling, right? So there after this there was a revolution towards conversational AI. What is the conversational AI? And AI is what? Artificial intelligence. The system or machine who is capable of human like behavior. So another one of the best human behavior is communication, conversation human does, right? So if system is able to conversate in the way human conversate with human, in that uh, area of learning or field, we call it conversational AI. And a solution that enables a dialogue between an agent and human, that is called conversational AI. Generally, conversational AI agents are known as bots. So it is start with bot. Nowadays, we have intelligent bots, uh, AI agents, and all that, right? So bot can engage over multiple channels. For example, web chat interface, email, social media platform, voice. These are the way of engagement. And text analytics. So in text analytics, NLP is the field of learning or uh, understanding the text. So machine would be able to understand text, human text, right? For example, I had a wonderful vacation in France. So with this sentence, what machine says that predominant language is English, sentiment is 88% positive, key phrases wonderful vacation, right? This is the word which gives the confidence that it is positive and negative, right? And key phrase is wonderful vacation and entities is France. So in this sentence, what is the entity? Entity is the France noun basically, right? So this is the NLP. So in NLP, we have speech recognition and synthesis. Okay. So In NLP, the system would be able to recognize the speech, means what human says it is able to understand, and that and with that, what it will do, based on the voice, it will convert into text, and that can be stored or extracted from my voice, and it should get into system to perform the action. So that's where we call speech recognition, and use the text to speech capability of speech service to generate audible speech from text. So that is another use case. From text to audio you can also generate. Okay. So another use case is translation. So for example, this is a one uh, bonjour, and it says that hello. Hello, then it says hola. So this is these are the translation use cases. Language understanding. So machine will be cap- in this discipline, machine will be able to understand human language. Means it should be able to understand entity and action, and it should be able to perform the action accordingly. So there shouldn't be a human intervention, right? The switching the default, switch the light on. When we are giving this instruction to Alexa or Siri, what it be doing that, it will figure it out what's the entity and what the utterance and what it's been asked, right? So it's got the light entity and utterance are switch on is the use case or actions. So that is the language understanding. Yeah, so we will learn principle of a responsible AI learn next, but in this one we will recap. We learned about touch upon types of machine learnings. It's uh, regression, from regression to clustering, classifications, and then computer vision. What is it? And then NLP, what is natural language processing. So we touch upon all these high level in machine learning. So yeah, so we will try to learn uh, next part into other session. So and with this we will yeah, so networks and deep learning we will be learning in more detail, which doesn't comes under machine learning, because let me share you here, you can see, right? So here artificial intelligence, machine learning. So far we learned more into deep learning, machine learning, deep learning, high level we learned upon. So the subset of ML which mimics the human brain, so uses artificial neural. So we will learn about artificial neural network. Then we will be able to decode clearly what is deep learning. And within the deep learning, we have this generative AI, right? And we will learn uh, uh, the generative AI, what is it and how it has been evolved. All right. So in this module, we completed machine learning. So that's all in this session. Uh, Feel free to write a comment in the feedback so that we can take it accordingly. Thank you.